We'll be first looking at how to find the mean of a given set of values. So the mean can be defined as the average of a given set of values. So there are three different scenarios. The first one is when you get a simple data set. So to calculate the mean for this, you add the total values given in this set and you divide this sum by the total number of values present in the set. So if you were to add all these numbers, you'd get 20. And there are 5 terms in this, or 5 numbers. And so you do 20 divided by 5 to find 4, which is the mean of this data set. In the second example, we have x values and the frequency, which means how many times that x value has appeared in the data set. So 2 has appeared once, 3 has appeared 6 times, and 4 has appeared 3 times. So to find the mean in this scenario, we multiply the x and f values for each row and you find the sum of them. And you divide the sum by the total frequency. So if I were to do this, 2 times 1 is 2, 3 times 6 is 18, and 4 times 3 is 12. If you were to add all this, you get 32. And the sum of the frequency is just the sum of these numbers, which is 10. So 32 divided by 10 is 3.2. which is the mean for this example. And in the last example, we have classes and frequencies. So in a class, we basically show that the values of x are from 5 to 9, or 10 to 14, or 15 to 19. We are splitting the rows into classes of x values. So the formula here is the same. However, when we say x, that is now the mid of each class. For example, in the class of 5 to 9, the middle of this would be 7. So we take x as 7 here. In the class of 10 to 14, the middle would be 12. So we take 12 as the middle for there. And lastly, in the class for 15 to 19, the middle would be 17. And so we take x, which is here, as 17. So if you were to apply the formula for this question, we would, for example, I said the x here would be 7. So 7 into 2 is 14. And then 12 is the middle here. So 12 into 5 is 60. And then 17 is the middle here. We have 17 into 3 here. So we find the sum of this, which is 125. And we divide by the total frequency. So which is again just the sum of this. So the total frequency is 10 in this case. So the mean of this data set is 125 divided by 10, which is 12.5. The symbol to express mean would be this, an X with a bar over it. So now we'll be looking at the median of a data set of values. The median can be defined as the middle of a sorted list of numbers. When we say sorted, it means the data set has been arranged in ascending order, which is crucial only when finding the median. So there are two different scenarios. One is when the number of terms is even, and one when the number of terms is odd. So when looking at the scenario where n is even, and in this case n is 1, 2, 3, 4, 5, 6, 7, 8, 8. So the number of terms is 8, which is an even number. So in this case, to find the median, we use this formula, which is 8 by 2 term plus 8 by 2 plus 1 term. So if you were to simplify that, that would mean the fourth term plus the fifth term divided by 2 is the median for this data set. So the fourth term is 8 and the fifth term is 10. So 8 plus 10 divided by 2 is 9. And on the right hand side, where n is odd, n is 1, 2, 3, 4, 5, 6, 7, 7. The number of terms is 7, which is an odd number. We use this formula, n plus 1 by 2 term. So 7 plus 1, 8 by 2 is 4. So the fourth term is the median of this data set. And the fourth term here is 8. And thus, the median of this data set would be 8. Now we will be looking at the mode of a certain data set of values. The mode can be defined as the value that occurs the most in a data set. So in this data set, we have 1, 2, 2, 4, 6, 8, 2, and 4. So we identify the value which appears the most, which is 2, as it appears thrice, which is more than any other number. And so the mode of this data set would be 2. Now we'll be looking at how to find the range of a certain set of values. You can define range as the difference between the highest and lowest values. So in this data set, we have 10, 12, 106, 2, 207, and 568. We first identify the maximum value, which would be 568, and the minimum value, which would be 2, and you find the difference between the two. In this case, we just subtract the 2 from each other, and we get 564, which is the range of this data set of values.
Here, which is also known as Q2, divides the data set into two halves. So you can say it divides into a lower half here and an upper half here. So if you were to further divide the lower half into another half, so if you divide this into a half, we divide this into a half, we get our quartile 1 and quartile 3. So the middle of the first half, so the middle of this half of data is a quartile 1, and the middle of this half of your data, so the middle of this will be a quartile 3. So to calculate the exact value of your quartile 1, quartile 3, we can just use these formulas here. So you can explain this with an example. So say we have 19 terms. So n plus 1 divided by 4. So 19 plus 1 divided by 4. So our fifth term is a quartile 1. So for example, our fifth term here would be 6. So we can say there is 6. So quartile 1 is equal to 6. And to calculate quartile 3, it would be 19 plus 1 divided by 4 times 3. That would be our 15th term. So whatever our 15th term is, that value will be our quartile 3. Also remember that whenever we're using these formulas, the data must be ranked in ascending order, so from least to greatest. So you can see here it's ranked from 2, 4, 4, 5, 6, 7, 8. It's all going from least to greatest. So our interquartile range is just our quartile 3, the value of a quartile 3 minus our value of a quartile 1. So in this example, we said that our fifth term is a quartile 1 and our 15th term is our quartile 3. So the value of the 15th term minus the value of the fifth term will give you our interquartile range. Minimum and maximum values. So if your minimum is 2, you place a vertical line on 2 on the number line. So this is just a number line. You can just place a vertical line at 2. And your maximum value, you can place another vertical line, 2, which is around the same length as the first line that you drew. Now you look at your Q1, median, and Q3 values. So Q1 value is at 3. So you draw a line that's shorter than the lines you just drew. So your Q1 is at 3, so a bit shorter than the lines you just drew. So then you do the same for your median, so the same length. And same for Q3. So Q3 is 8, you draw a vertical line at 8. Sorry. So these three lines, so Q1, median, and Q3 are the same length, and your minimum and maximum are a bit longer. So only for your minimum, maximum, and median, you connect these three. So only these three lines. So you can connect these three, which makes sort of a box. And then you connect the box to the minimum and maximum value. So remember, initially you create a box only for the Q1, median, and Q3 values, and then you extend the line to the minimum and maximum value. So this is how you draw a box in Whisker diagram.